Hey kids, so this lesson is about using special factors to solve equations. So basically that means that this is from 21.3 in the ebook, and so that you'll use this for that homework, but also for the last exit ticket in the packet. Also, reminder, if you haven't already done these, obviously you're watching this YouTube video, but please make sure you do the homework by today. It is due today, and also the Khan Academy for Double Dose. So make sure you've done that if you have not done it yet. So I'm going to skip ahead to right here. We're going to start with this as our first problem. So my goal with all of this is really just to show you some examples of factoring, different strategies or techniques that I use to help you go through. And that's really what this lesson is about. It's just really seeing different ways to factor problems and to get the answer. So this one says to factor the perfect square trinomial. So one common thread that you're going to see in this entire lesson is that this actually goes back to one of the previous lessons we did. I think it was at the end of chapter 19, where we talked about how, what if you have a plus b times a plus b, so the same thing times itself, and you FOIL it out. What do you get? And that's, if you remember, a squared plus 2ab plus b squared. And we also talked about, what about a minus b times a minus b, or a minus b squared, which would be a squared minus 2ab plus b squared. And we also talked about, finally, a plus b times a minus b, which, if you'll remember, the outside and the inside terms cancel each other out when you FOIL it out, so you end up with a squared minus b squared. And those are all shortcuts to foiling. So this lesson, if you want to think about it that way, kind of goes exactly with that lesson. This lesson talks about shortcuts to factoring using those same exact tricks. So let me start this problem off by noticing, does each of these terms, and let me see right here. So there's a term, there's a term, there's a term. And so what I'm looking for is, do each of these terms share something in common? And they do. So what I notice, for example, is that all of these terms have a common factor of 5 and a common factor of y. Or I can just say they all have a 5y. So what I'm going to do is I'm going to factor that out. And when I say factor that out, I don't mean factor like write the binomial terms. I mean literally like divide it out or pull it out. So for example, in 5y cubed, I'm going to pull out 5y, and I'm going to have parentheses. So from 5y cubed, if I pull out a 5, is there a number there anymore? And the answer is no. The 5's gone, right? It'll be like 5 times 1. I pulled out a y, but what's left is still a y squared. Now, if you didn't understand that, do this real quick. Multiply that back out, like pretend it's distributive property. What is 5y times y squared? Well, you'd get 5, and then with the y's, remember you add the exponents. The y on the outside has an invisible 1. 1 plus 2 is y to the third. So it's like the opposite of multiplying, aka dividing. It's like anti-distributive property. So you're doing the opposite of distributive property. Let's look at the next term. So it's a plus, because there's a plus in the original problem. I've pulled out a 5. I've divided by 5. So 50 divided by 5, that leaves me with 10. And y squared, I've pulled out one of those two y's, so I still have a y. And again, do distributive property and multiply it back out if you didn't get that. What's 5y times 10y? Well, 5 times 10 is 50. Y times y, that's y squared. Right? That's how I know I did it right. And then finally, I have another plus. And that's going to be, I believe, 25. That should say 25. There we go. 25. And then I already pulled out the y, so that's it. Okay, so let me pause here. That's like my step number 1, if you want to call it. Check for any like common factors that you can pull out, so to speak. And again, you can double check your work. Do distributive properties. So for example, 5y times y squared, that would be 5y cubed. 5y times 10y, that would be 50y squared. And then 5y times 25 would be 125y. So I know I did it right. Okay, so let me erase all these little lines because they're going to be confusing otherwise. All right, so now the 5y on the outside, I'm going to leave that alone, but I'm going to factor what's on the inside. And again, it's the exact inverse, or the exact opposite of the lesson that we did where we FOILed out. So basically, I'm looking for, how do I factor the y squared plus the 10y plus 25? And it has to be, I'm really looking for the exact same thing multiplied by itself, if possible. So the answer is quite simple. The 5y is going to stay there. And this is going to be right here, y plus 5 times y plus 5. And just imagine foiling that out real quick. Y times y, first times first, that would give you the y squared. Outside times inside, that's plus 5y. Inside times inside, that's another plus 5y. 5y and 5y, that's how I get the 10y. Then last times last, 5 times 5, 25. So really, remember, all I did was I looked for two numbers that multiply to 25, add to 10, and I know because of what lesson I'm on that it's probably going to be the exact same number, so that was 5. And the last thing I should point out is, by the way, I should probably label that as step 2, and if you want to write something down, step 2 would be just factor it using one of the shortcuts. And then step 3, if you want to call it a step, I mean, these aren't, just to be clear, these aren't really steps, this is just how I'm doing this problem in my head. If you want to call it steps, sure, right? But the last thing I'm going to do is I'm kind of condense what I have. So the 5y I'm going to leave, but I'm going to rewrite y plus 5 as y plus 5 squared because I'm multiplying it by itself 2 times. So let me just make this a little bit nicer. That's a 5. It's 5, and I'm going to box that off. That's my answer. That's all there is to it. So that's how you factor a trinomial like this. Now let's move on to the next problem. All right, so on this problem, I have 900z squared plus 420z plus 49. Now, right off the top of my head, I'm imagining you all sitting there listening to me, thinking, "But the whole thing is too much. I can't." Okay, so calm down. Remember, these are all shortcuts, so there's like an easy way out for all of these problems. So it's like a pattern recognition, right? If you're good at pattern recognition, you're going to see exactly what it is the problem's asking you for. And even if you're not good at it, practice, because that's exactly where you're going to be soon enough if you keep practicing these problems. So again, like I did in the last problem, my step number 1, if you want to call it that, is do all these things have the same thing in common. So like I see that the first 2 terms, like this has a z squared, this has a z, so they both have at least a z. The last one doesn't have a z, so I can't pull out a z. Then I ask myself, okay, well, 900 and 420, I mean, technically they share, like, I don't know, a 10, a 20, whatever. But the 49, I mean, that throws the whole thing off. So my point is that these 3 terms don't actually share anything in common. So when I factor this, it's going to be really simple. I'm just going to have 2 binomials. Now, let's think about this. I'm going to use the same techniques that I always do, keeping in mind that when I'm done with this, I should be able to condense from here. I'm just going to put this as like line number 1. Again, these aren't really steps, but if you want to think of them that way. So I'm multiplying the same thing by itself, and if I multiply the same thing by itself 2 times, it's going to be written like on line 2, blah, 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 squared. So I have to ask myself, okay, let's look at that first term again. 900z squared. What times what gives you 900z squared? And off the top of my head, I'm pretty sure it's 30z times 30z. Check in a calculator. But is 30 times 30 900? It should be. Let me just 30 times 30. 0, 0, 0, 0, 9. Yep, it's 900. So it's kind of like, I guess you could say, what's the square root of this and what's the square root of that? If you know the square root of the first term and the last term, you pretty much know the answer. So let's write it out. The square root of 900z squared, or what times what is 900z squared, is going to be 30z times 30z. That's my first times my first. Now I'm ignoring the O and the I. I'm ignoring the middle term for now. I'm going straight to last times last. What times what is positive 7? It's positive 49. It's either 7 and 7 or negative 7 and negative 7. The reason I'm writing positive 7 is because now I look at the inside term and I see that it's positive. So the only way that it's going to multiply to a positive and add to a positive is if everything's a positive. Now, just to double check, let's make sure, and I'm going to kind of do this, I'm going to squeeze in the step here. Let's flow this out and make sure we get it right. So first times first, 30z times 30z, that's 900z squared. Outside times outside, 30z times 7, 7 times 3, 21, add a 0, so that's plus 210z. Inside times inside, that's another 210z, which it's supposed to be, right? I mean, that's the whole point of the shortcut. By the way, 210 and 210 do, in fact, add up to that 420 we were looking for. And then last times last is 49. So I know I did it right. So that's like me checking my work. Yay, I did it. And then just put it all together. So 30z plus 7 times 30z plus 7 is the same thing as 30z plus 7 squared, because you're multiplying the same thing by itself 2 times, and that's it. All right, let's check out the next one. All right, this one is the difference of two squares. And again, this is another one of those shortcuts. Now, the first thing that pops out to me with this problem is that where's the middle term? I see my first times first, but then the O and the I in FOIL, they're missing. Usually it's something squared plus or minus something x and then plus or minus a number, but that middle term is missing. Now, if you remember, that shortcut was a plus b times a minus b. So the same thing multiplied by itself with a positive and with a negative, because what happens is that the outside and the inside will cancel each other out, and that's how I end up with a squared minus b squared. That was one of the shortcuts we talked about. So that means when I write the factors for this, it's going to have to be something plus something times something minus something, the same numbers in both, just one being added, one being subtracted. So first of all, how do I get the x squared? Well, there's only one way to get x squared, and that's x times x. How do I get 324? So again, basically, what is the square root of 324? I actually have no idea what that is. I think it's maybe 18. Let me just double check. 18 times 18, 8 times 8 is 64. Wow, I can't do math. That's not what it should say. It should say 4. 6, 8 times 1 is 8, plus 6, that's 14, 0, 18, there we go. Yeah, I think I did that right. So 4, 12, 1, 3, 324. Yeah, I got it right. So that's 18. So that's going to be plus 18, minus 18. And actually, I'm done. Let me just FOIL it out to prove that I got it right, which is what you should do as well, right? So first times first, that's x squared, outside times outside, minus 18x, inside times inside, plus 18x. That's what I was talking about, right? These two are going to cancel because they're the exact same thing. And then I already know that positive 18 times negative 18 is negative 324. So I know I did it right. So my answer was actually back here. And that's it. That's all I had to do. All right, this one, same idea, right? Notice that the middle term is missing. So I know that whatever it is, it's going to be something plus something, something minus something. And with these, keep it simple. So like, for example, when I ask myself, well, how do I get 16y to the fourth? You might be thinking, oh, well, that could be 16 times 1. That could be 8 times 2. But remember, it has to be the same thing multiplied by itself. So 8 and 2 are not the same number, right? 16 and 1 are not the same number. So the only way you get to 16 by multiplying the same thing times itself is going to be a 4y and a 4y. And by the way, notice that the exponent is to the fourth. So I'm going to put 4y squared, because remember, when I do first times first, when I FOIL this out, 4y squared times 4y squared is going to be 4 times 4, which is 16. Y squared times y squared, add the exponents, 2 plus 2, that's y to the fourth, right? And then the last thing is, well, how do I get to 4y squared there? Well, what times what is 4? It has to be the same thing, so that's going to be 2y and 2y. Because again, 2 times 2, that'll give me 4. Y times y, that'll give me y squared. Check my work just to be sure. First times first, I already did that one, right? So that's 16 y to the fourth, outside times outside. So let me just write this here. So this is the outside, this is the outside, right? So 4 times 2, and there's a minus, right? So that's minus 8. Y squared times y is y cubed, 2 plus an invisible 1. Inside times inside, plus 8y cubed, and then last times last, minus 4y squared. These two cancel. Yay, I did it right. And there's my answer. Not too bad, right? All right. This one says to solve this equation using special factors. So basically it's saying do exactly what we were doing and then use the zero product property, set them equal to 0, and find the answers. Okay, not that bad. Let's think about this. I've got a 9 and a 1. So what times what equals 9x squared? Now, if this problem is as easy as the last problems, this will be a 3x and a 3x, right? Instead of doing 9x and 1x, it'll just be 3 and 3. So let's try that out. Hopefully it's that easy. If it's not, then we try something else, right? So I'm going to go ahead and factor this. And all of this is going to equal 0. The equal 0 part is just like a hint to you that basically says keep going. Don't just factor it, and then set them all equal to 0. That's really what you should do when you see the equal 0. Right? So I'm going to try out 3x, and I'm going to try out 3x. I see that I have to multiply to positive 1, but add to a negative 6. So the only way you multiply to a positive, but add to a negative, if you weren't aware, is by doing a minus 1 and a minus. So a negative times a negative will multiply to a positive, but will add to a negative. So let's see if this is right. First times first, 3x times 3x. I'll just write it down for you. That's 9x squared. Outside times outside, minus 3x. Inside times inside, that's another minus 3x. There we go. Negative 3x and negative 3x add up to a negative 6. So I know I did it right. That's great. So again, the hint here was that because it's a special factor, I know that it has to be the same thing times itself. So this is like my, if you can call it, this is like your A, and this is like your B. So right, this is like saying the same thing as 3x minus 1 squared equals 0. It's the exact same thing. Now this one actually says to solve it, right? So I'm going to have to take it a little bit further. And I'm going to set each of these factors, which, I mean, they're the same factor, so I only have to do it once. And I'm going to set them equal to 0. So I'm going to write 3x minus 1 equals 0. And normally I'd write the other factor equals 0 as well, right? But again, same thing, so I don't have to. Add 1 to both sides, and I'm going to get 3x equals positive 1, and then divide both sides by 3, so x equals 1/3. That's it. That's what the value of x is. All right, moving on. This one says to do the same thing, displaying a little funny, but no biggie, we will be fine. So now this one, let me actually rewrite it because there's a trick to this problem that I want you to pick up on. 729x to the 4th minus 9x squared equals 0. Now, there are bigger exponents here, but I want to bring you back to the very, very first problem we did in today's lesson, which is where we looked for, do they have anything in common? This one is an example of that. This one has something in common. Notice that 729 and 9 are both factors of, it's kind of a giveaway, but they're both factors of 9. X to the 4th and x squared both share at least an x squared. So before I actually try to solve this problem the way that I've been doing, I'm going to go back to that first problem I did in today's lesson, and I'm going to do what I did there. So it's kind of like a pre-step, so to speak. So I'm going to factor out a 9x squared. And remember, that's kind of like dividing, right? Okay, so if I pull out a 9 from 729, 729 divided by 9, let's think about this. 9 goes into 72. How many times? That's 8, right? And then 9 goes into itself 1 time, so that should be 1. So 81 times 9 should be 729, assuming I didn't mess that up. And then x to the 4th divided by x squared will leave me with an x squared. And again, you can check your work simply by doing distributive property and multiplying back out. So 9 times 81 should be 729. I mean, check my work. I'm kind of doing this in my head, so I'm hoping that's right. And then x squared times x squared will add the exponents, so that'll be x to the 4th. And then minus 9x squared divided by 9x squared. Well, I pulled everything out, so I'm just going to put a 1 as a placeholder. And again, all you got to do is do distributive property to check your work. So 9x squared times 81x squared should be 729x to the 4th. 9x squared divided by 9x squared is just 1, and there's a minus sign in the middle because, well, I started with a minus. And then all of this equals 0. Okay, so I'm going to go ahead and keep factoring. I'm going to leave the 9x squared. I'll go ahead and let's call this step 2. I'm going to leave the 9x squared there, but now in the middle, these are special factors, right? So it should be the exact same thing multiplied by itself. So I should have this times this equals 0. Notice that the middle term is missing, just like the last couple problems. That means one of these is going to be a plus, one of these is going to be a minus. The square root of 81x squared is going to be 9x and 9x, because 9x times 9x is 81x squared. And then the square root of 1 is, well, 1. Okay, now just real quick, maybe off to the side, I'll do it up here. I'm going to FOIL it out, make sure I did it right. 9x times 9x squared, outside times outside, that's minus 9x, inside times inside plus 9x, good, they cancel, and then last times last, negative 1. All right, so now notice, and this was my, more or less my final step. I mean, technically there's another step, but anyways, notice that instead of 2 factors, I actually have 3. I have a factor, and a factor. The last 2 are the same thing, right? But what I'm going to do is I'm going to set each of them equal to 0. Oh, by the way, I just said the last 2 are the same, but they're not because one's a positive, one's a negative. So scratch what I said. So anyways, I'm going to set each of these equal to 0. So I'm going to write 9x squared equals 0. I'm going to write 9x plus 1 equals 0. And I'm going to write 9x minus 1 equals 0. Now the first one, 9x squared equals 0. Divide both sides by 9, so that's going to be x squared equals, well, 0. And then to get x by itself, the opposite of squaring something, if you remember, is square rooting it. So if I take the square root of both sides, the square root of x squared is just x, and the square root of 0 is still 0. By the way, this little piece right here, I'm going to star this because that's what the next lesson, the next exit ticket is going to be about taking the square root and finding answers that way. But we'll get to that later. The next one, 9x plus 1 equals 0, so I'm going to subtract 1 from both sides. I'm going to get 9x equals negative 1. Divide both sides by 9. X equals negative 1 over 9, because I divided both sides. And then over here, add 1 to both sides, so that's 9x equals positive 1. Divide, x equals 1 over 9. That's positive. So there are my 3 answers to this problem. Not too bad, though. All right, and that's it. That's the lesson for today. By now, you should be really good at factoring and foiling and all that stuff. Next couple lessons, we're going to go ahead and move on to other ways to solve quadratic equations. Thanks for listening.